Okay, here also we'll continue with the numericals. Okay, go to PDF, go to page number 22, not sorry, question number 22. Okay, not page number, question number 22. In that question, what they told that there are four charges. The charges order is given to you. Okay, kept in a four vertices of a square. The square side is also given to you 1 meter. Now, first of all, now how to place those charges on the square? Okay, you have to start with any one vertex and go either in clockwise or in anti-clockwise, any one direction. Okay, don't start substituting randomly the charges, then the numerical will be wrong. First thing you need to keep in mind. Okay, clockwise or anti-clockwise. We can start from any vertex. You can start from here also. You can start from here. You can start from here. No problem. You will get the same answer. Okay. Next, there is one more charge which is kept at the center of the square. Okay. Now, with respect to this, you have to understand what is the center of a square. Now, in your class 9 or 8 geometry maths, if you go, center of a square is where the diagonal of the square intersect. Okay, where the diagonals intersect. There is one more definition. Keep in your mind, we will use later on in magnetic effect of current chapter, where the side bisectors intersect. That means if you make a side bisector like this, bisecting these two sides, and a side bisector like this, bisecting these two sides, they will also intersect at this center of a square. Okay. Next geometry you need to remember, like in a square, the diagonals are equal and they perpendicular bisect each other. The diagonals are equal, that means these two sides are equal, these two diagonals are equal, and they perpendicular bisect. What does that mean? That is, this angle is perpendicular and the bisect, these are equal. This implies all the distances from center to the vertices are equal. That's why I'm taking it as OA, OB, OC, OD, take as R. Okay. Now let's calculate that R value. Okay, how to calculate R? In this, can we apply Pythagoras theorem? AB square plus BC square equals to AC square. From there we get AC equals to root 2. Now what is R? R is a half of AC. Half of AC. From there we get R equals to 1 by 2 root 2 meter. Now we will not use this 1 by root 2 again and again. Okay. We will take it as R. Later on at the end we will substitute the values. Okay. Now this figure is incomplete. Okay. I have to make something here. So please don't copy right now. Wait for some time. Okay. Now see here. We need to find net force at the center, at this charge which is kept at the center. Now, I told you in the previous video, in the numerical, how many forces this charge will experience. Now, for this you need to see how many charges are there in the vicinity of this. So, in the vicinity of this, there are 4 charges. That means this charge will experience 4 forces. Okay. Now, what are those 4 forces? Now we'll start making the figure 4. Number 1. Now, force on O due to A. See, I have written force on O due to A. Now, this statement I haven't written for this, so you don't have to write in an exam also. Just once you write, it understood later on that this is in this way. Okay, force on O due to A. Now, you have to understand what is the direction of this force. Both are positive. That means this charge is placed here. It will try to move in this direction. Okay. Now, don't make it in this way. Asani banana. You make a mistake like this. You draw like this. No. How can be the force in this direction? We need to find the force here. This charge is already in this here at this point. That means what will happen? This charge will move in this direction. This is force on O due to A. Okay. Now, force on O due to C. O is positive, C is negative. That means this O will try to attract. So it will move in this direction, force on O due to C. Okay. Now force on O due to B. This is positive, this is positive. That means this O charge will repel force on O due to B. Similarly, force on O due to D. This is negative and this is positive. That means this charge will try to attract, come in this side. So it will come this side, force on O due to D. Now the figure is complete. Now the whole thing can copy it. Okay. So we understand there are 4 forces acting on O. These are the 4 forces. Now let's calculate these 4 forces. FOA, force on O due to A. K. Why I'm writing K? Why not I'm writing 1 by 4 pi epsilon? Because it's a tedious job to write 1 by 4 pi epsilon every time like this, okay? So best is what? थोड़ा simple way में लिखते हैं K all the time we write K. At the end I will substitute K equals to 1 by 4 pi epsilon. Okay. Now K charge at O 1 microcoulomb. Micro is not SI unit, so 1 into 10 to the minus 6. Then into Q1 हो गया, into Q2 charge at A 0.1 10 to the minus 6 divided by the distance between OA. That distance I am taking it as R divided by R square. Now this force is which nature? Repulsive nature. Because this is positive, this is positive. Okay. Now force on O due to C. Force on O due to C. Okay. Again K charge on O 1 microcoulomb 1 into 10 to the minus 6 into minus 0.3 microcoulomb. Now in the theories I have told you, when we write the expression of forces, we don't take the sign. So I will not take this minus sign. I will simply write the magnitude 0.3 10 to the minus 6 by what is the distance between these two? R square. And this force is attracting. This plus 1 microcoulomb will attract towards minus 0.3. Okay. Similarly, find FOB, force on O due to B. K, force on O, charge on K, charge on O, charge on B. Okay, divided by distance between O and B. Again the nature. In this way we got the forces, all the 4 forces. Now we need to find net. So there are 4 forces. How to find net? We can see that these 2 forces are acting in same direction. Okay, in theory I have told you, since they are acting in same direction, we can add them. So I am taking that force as F1, FOA plus FOC, because they are in same direction, we are adding them. Okay, now very important thing in numerical, don't start solving these things, okay, don't start solving the values. We will solve it at the end when we have nothing to do. We will not solve in any numerical, okay, we will not solve in between the numerical, okay, because at the end we get things common, we should take it out. So we will not do a laborious job out here, okay. So see, FOA and FOC, we can see something is coming out common, K is coming out common. 10 to the minus 6, 10 to the minus 6. If I multiply, it becomes 10 to the minus 12. Here also we have 10 to the minus 12. So we are taking out 10 to the minus 12. Then R square. We take out R square common. Now what we left with? Here we left with 0.1 and here we left with 0.3 plus 0.3. We got 0.4. Okay, again I am not substituting the value. We are keeping like this only. Next, these 2 forces are in the same direction. So we will add them. Again, take out the common terms. Now see, F1 and F2, they are same. Okay, understood? So again, we will not calculate this. Just I am writing these 2 are same, so we can use only one value. Okay. Now what I get? Initially we got 4 forces. We converted the 4 forces into 2 forces, F1 and F2. Now how the figure will look like? That O is here towards D and towards C. Towards C, these 2 forces I've added and made that F1. So I'm naming it as now force F1. Towards D, we have these 2 forces. Towards D, we have these 2 forces. I've named as F2. So I will take it as F2. Now, out of 4 forces, I've converted the 4 forces into 2 forces. And we know they make an angle 90 degree. Square, diagonal, bisect, perpendicularly. Now, 2 forces making some angle, therefore net force will be how much? Formula F1 square, because they're making angle F1 square F2 square plus 2 F1 F2 cos it is angle 90 here. Okay, these 2 are equal, so I'm writing same F1 F1. So 2 F1 square root 2 F1. Now substitute the value. Now we have written K is 1 by 4 epsilon and this value we know 9 10 to the power 9. Now solve this and you will get the answer, you will get Newton. Okay, this is the end of the question solution which is given in the book. Now what I have told you initially, like in the question is mentioned magnitude of force. It's mentioned very nicely magnitude. So since they have asked you only the magnitude, so I will calculate till here magnitude. Now if in the question magnitude word is not mentioned, okay, they only ask you find the force. Try to understand the difference between both the things. If they ask you only the magnitude, your job is over. You calculate the magnitude. But if they ask you force, Then the job is to calculate both magnitude as well as direction. So magnitude we got. We need to find extra direction. Now what is direction? There are two forces. This is the F in between these two. Direction is what? Angle of the net force with respect to any one angle, any one forces. Either you find this angle or you can calculate this angle also. Any one angle you can calculate. So I am calculating this angle tan beta using the vector concept. Beta is the angle with F2. So I am writing F2 here. F1 cos in which angle 90, F1 sin 90. From there we got 1 because they are equal. Beta is 45 degree. Okay. Okay, now you go to question number 16. Okay, in that question, there are two small spheres is given. Two small spheres. Okay, each having mass m. That means the masses are m, and they have this charge q, same charge q. Okay, and from the same point using a thread. Okay, there are threads. Two threads are there. Okay, at the end there are two spheres which have same mass and same charge. Okay, this is the normal condition. This forces Ff, these things are not there initially in the question. Okay, this is the normal case. Now again in the question they are saying, okay, if theta is the angle, each string makes the vertical when equilibrium has been attained. Now what is this? Theta is the angle. So suddenly how the angle can come? They are hang like this, two threads hang like this. So they will be hanging this way only, na? This should not be any angle. So now we have to think on our own कि ये angle आएगा कैसे? So since these two spheres have same charges now, so what will happen? They will experience force, repulsive force. Okay, they will experience repulsive force and they will spread apart and attain an equilibrium position. Okay, what is the equilibrium position? When the net force is 0. Okay, so that condition is here. So these two forces, these two charges are experiencing force and they come to a equilibrium position. At that equilibrium position, in the question is mentioned, theta is the angle of the thread with the verticals. Okay, this is the vertical we have, this is the angle. Now, again, these forces will not be given to you. So at this case, at this point, okay, this sphere at an equilibrium. Now why this sphere goes in this direction? Because of this repulsive force. Okay, that's why it's the good direction. Now, since this body at an equilibrium, that means the total force acting on this sphere should be 0, since it is in equilibrium. So let's see how many forces are acting in this sphere or in this small ball. Okay, so one is repulsive force which is acting at this position. One is mg, fundamental, since the body has some mass, there mg. Next is, since it's a thread, that means there is some tension is also there, which is acting in this direction. Okay, now there are three forces acting on this ball and it is in equilibrium. So since it is in equilibrium, three forces are acting. Okay, therefore we can use Lami's law. Only three forces are there. We don't have to go for resolution now, we can go for Lami's law. Okay, now what the Lami's law say? Force by sine of angle between the other two forces. Okay, so what I want, for applying Lami's law, we need angle between each forces. So what is the angle between these two? 90, I can see. What is the angle between these two? I don't know. What is the angle between these two? So I don't know. I know this angle. So anyhow I have to relate this angle here. So what I am doing, for that I am doing a construction. I am drawing a line parallel to this. Why? If this is theta, then this will be also theta. Okay. Now I understand what is this angle? 180 minus theta. And what is this total angle? 90 plus theta. Okay. So for applying Lami's law, we need angle between the forces. For that use, I have drawn a reference line so that I can relate this theta with here. Okay. Now we got the angles between all the forces. Now we can apply Lami's law. Why we apply Lami's law? Because in the question it's mentioned equilibrium and there are only three forces are there. Okay. The force F divided by sine of angle between the other two forces. These are the other two forces. What is the angle between these two? Sine of 180 minus theta equals to mg by sine of angle of other two forces. These are the other two forces, F and T. What is the angle between these two? 90 plus theta. This is 90 plus theta, sine of 90 plus theta equals to tension by sine of these two, sine of 90. Okay. Now, in the question, they ask you to find, prove Q equals to something, right? In that expression, there is no discussion about tension. You can see the expression in the book. Okay, page question number 16. Go to question number 16. You will see that there is no tension is given. Okay, tension के बारे में कुछ नहीं है. Okay, so that's why I'm not taking this. I'm only depending on these two. I'm interested on these two. So I'm writing these two here. Okay. Now F by sin 180 minus theta is sin theta. Mg by sin 90 minus plus theta is cos theta. Okay. From there we got F equals to mg tan theta. Okay. Now we don't need F, we need Q. So how to get Q from F? Use the formula. What is F? Force between these two. Okay. So these two charges let they are separated by a distance of r. This is not given to you. I am taking it as r. Okay. Then what is the force? 1 by 4 pi epsilon Q into Q by distance between these two, r square. Okay. Now I need Q one side. I'm keeping the Q one side, Q square, and rest other side. Okay. Now again match with the expression which you need to prove. 4 pi epsilon we got, mg we got, tan theta we got, but r, there is no like discussion of r in the question. In the question they told that the length of the thread is L. R is not R, so I have taken on my own. So my job is to now convert the R in terms of L. You have to convert R in terms of L. Okay. Now how to convert R in terms of L? So what are the parameters we already have? We have theta, we have L, and we need to convert R. So if the total distance is R, then this distance is R by 2. Okay. Now how to convert R? Now you understand why we need to convert R into L? Because my question is in the form of L. Answer is in the form of L. No R. R I have taken. Okay. Why we did not consider T here? This you can write. Okay. For copying you can copy the whole thing. Okay. Understand what I'm saying? But we are not considering this. Why? Because we don't need tension here. There is no discussion of tension in the question. So we don't need any tension on it. Okay. So how to convert this R? So now in this triangle, see this triangle, we have theta, we have L. With respect to this theta, this is perpendicular and this is hypotenuse. So what we will do? We use sin theta. Sin theta equals to perpendicular by hypotenuse. Okay, sin theta. Understand what I'm saying? This is a right angle triangle. Perpendicular by hypotenuse. From there, what is R? L sin theta equals to R. So we got 2L sin theta. Now substitute Q square 4 pi epsilon naught mg tan theta into R square 4L square sin square theta. Okay. From there we will get Q. What is Q? 2L sin theta under root 4 pi epsilon naught mg tan theta. Okay. So we got the value of Q. Understood, class? Thank you. Okay, one more last thing. Question number 13. Okay. Now, this question is important and I will not solve the whole question here. I will just give you a small description how to go for this type of questions. Okay, because it's very important. What I want is you solve it, and if you have any doubt, you ask me. Okay, and you have already solved it. Now see, try to understand. Did your thinking process is exactly the way what I am saying here? So what is the question here? There are two spheres, A and B, and their charge is given to you. Okay, QA, QB. These are given to you. Okay, and they saying a third uncharged sphere, this C uncharged, that is what? QC will be equals to 0 coulomb. Okay, is brought in contact with the first, then brought in contact with the second, and afterward removes. Matlab C first contact with A, C then in contact with B, and find and then you moved, and then what is the new electrical force between the first two charges? The question is that these charges are given to you. Okay, there is one uncharged is given. It's not necessary that this should be uncharged. It can be charged also, no problem. If it is charged, take that value here instead of 0 coulomb. Okay. Now the question is, C will be kept in contact with A, then B. Okay, and then after this all process of contacting over, then the A and B will be separated at a certain distance here. Okay, and find the force. This is the question. Now the thing which you need to thought is that when these pairs are in contact, what will happen? So in theory, I taught you when two bodies are in contact and these bodies are different concentration, charge concentration, diffusion होता है. Okay, diffusion होता है. Diffusion क्यों हो रहा है? Because of charge difference. These two bodies will have different charges. So diffusion कब तक होगा? Till both the bodies acquire same charge. So this is my funda. Again I am saying, when two different bodies having charges are in contact with each other, okay, what will happen? Diffusion of charges occur. Charge flow from one body to another. Now why this diffusion occurs? Because of charge difference. Now till what point this diffusion will occur? Till both the bodies will have same charges. So I will use this concept. So what I will do, when C with A, C is in contact with A. Okay, so what will happen? Diffusion will happen like this. Okay. Now diffusion कब तक होगा? जब तक दोनों का charges same ना हो जाए. That means new charge, the new charge, this is the new charges, will be what? Total charge divided by 2. दोनों का मिला के जो charge था divided by 2 वो आधा आधा हो जाएगा दोनों में. Okay, both will have same equal charges. Okay, now initially QC was 0, Q you have something, put that, you will get new charge at A. You will get a new charge in A. Okay, now C initially was having 0 coulomb. It was in contact with A. After in contact with A, now C acquire a charge QC. Okay, now C is no more uncharged, it has some charge. Now C with B. Now C is in contact with B. So B has a charge QB, C has a charge QC dash. Now the new charge will be what? Total charge divided by 2. Okay, QC dash plus QB divided by 2. So now we got new charge in B, we got new charge in A. Now these two charges QA dash and QB dash are separated by a distance. That distance is given to you question. Then how to find force? 1 by 4 pi epsilon. That new charge you got divided by r square. Okay. Now this is the end of the electric Coulomb force. Okay. The Coulomb force topic is over. We understand the theory. We understood all the numericals here. Okay. And next we will start electric field. You will get this video of electric field after 2 to 3 days. Okay. Till then, stay safe. And I will be sending you an email class. So please read that email nicely. Okay. Let's see how we can go through further. Thank you very much.